Tuesday, the 13th of April, okay? You guys will be able to solve quadratic equations by square rooting. Section 9.2, actually, it's going to be 8.2. I don't know what kind, 9.2. It used to be chapter 9, then we changed the chapter numbers. Now it's chapter 8. Solving quadratic equations by using square roots. So, we learned for an entire chapter how to factor. Factoring is this incredibly handy method that is used in all stages of later math in some way. This is another technique to solve quadratic equations. Factoring is one way. Factoring, as we found out, does not always work because sometimes it's prime. Okay? This method also will not always work, will not always be very effective. Okay? And so we will find other ways actually next class to learn how to make it more effective at times and to cover a broader scope of problems. Okay? And then we're going to learn another way after that to figure out how to solve quadratic equations. So we're going to keep adding more tools to our tool belt, so to speak, of how to solve these problems, okay? And how to approach different scenarios. Because sometimes, just like in life, when you go up to approach a certain problem, you can't approach two problems necessarily the same way, can you? Okay? Sometimes you have to approach problems differently. Sometimes you can approach them the same way. Sometimes they have to be approached differently. So just like that in math, we have to learn, when do we approach this type of problem this way? When do we approach it this way? And some of that carryover is also that problem-solving skills for real life of trying to figure out what you have, taking that moment to analyze it, and say, okay, if I do this, what will happen? If it has this cause, what's the effect? Okay, have you guys talked about cause and effect in other classes? Okay, if you have this cause, if I do this to both sides of the equations, what's going to happen? If I say this to this person, what's going to be the effect of that? Same kind of thing. Other applications of this, once again, quadratics really lend themselves to a lot of stuff with like business, for example, as far as maximizing or minimizing profits, okay, or expenses. And then also sports, okay? So a lot of times in sports like maybe baseball or golf, Masters is going on right now. You'll see as soon as the ball is hit, thrown, whatever, you can see it on the screen, this little arc of the ball and how it moved, right? They'll trace it and they'll say it moved at this speed, it hit this height, it's going at this angle, all that stuff. You guys know what I'm talking about at all? Okay? That's done through a lot of this type of stuff that we're working on this chapter, actually. It's pretty cool. Okay? A more advanced version of that, but at its core, this is what that is. All right, so we can solve this problem by factoring x squared minus 9 equals 0. We've been doing that. That's a difference of 2 squares right there. There's no GCF, and it's a difference of 2 squares. So we say x plus 3 and x minus 3 equals 0. Those are the two factors. Questions on that? That's what we've done before. So then we set each factor, equal to 0. And we solve. Minus 3. X is negative 3. Add 3. X is 3. And we say, hey, those are our two answers. Now we're going to solve this problem with using another method and to show, hey, both methods work because they get the same answer. In math, if you use two methods and you end up getting the same thing from both methods, you say, was that a coincidence or is it actually true? Does it actually work both ways? And if you did all of your math correctly and didn't just make a mistake somewhere here or there, then you say, then it must just be true that they end up accomplishing the same thing. So what we have to do is we have to isolate the squared term. Isolate means to do what? Get it by itself. We've been working on isolating variables a lot of the year, right? Okay. So to isolate, we need to get it by itself. So we say isolate the squared term. I'm going to underline that, squared term. So we say, hey, what is being squared here? X is being squared here. X, we actively see the exponent of 2 on. Now 9 is a perfect square, but X is being squared. So how do I get X squared by itself? I have to either move the 9 over or move the X squared over. Which would you rather do, though? Probably move the 9 over. Okay. How do I move that 9 over? Add 9. And so I get x squared equals 9. So I successfully completed step 1. I isolated my squared term. On one side of the equation, all that is there is whatever is being squared. In this case, it's x being squared. My next step is to take the square root of both sides. So just like squaring something is an operation, we have adding, subtracting, multiplying, dividing are all operations, right? We also learned that exponents are operations. Here's another operation. In math, you actually keep learning about more and more operations that... Wait, there's more of these? Yeah, there's a ton of operations in math, actually. You just mainly focus on 4 of them all of your life. So exponents were the 5th one that we learned. The next operation we're going to learn now is called the square root. I said before, hey, what would the square root of 16 be? 4, right? It's saying, hey, whatever times itself is that number. So what we do is we take the square root of this side. Because what's the square root of x squared? X. Because mathematically what happens is just like addition and subtraction, they undo each other, right? Like when we added 9 to negative 9, it undid that. When we square a square root, they undo each other. They're called inverse operations. They're opposite operations of each other. So a square and a square root undo each other. So when we square root that left side, we're left with x. Now, we've learned, though, if we do something to one side of an equation, what do we have to do? Do it to the other, right, to keep it balanced. So I have to square root the other side of the equation as well. So then I ask, okay, well, what's the square root of 9? 3. Now, wait a second. 3 times 3 is 9, right? Is anything times itself 9 as well besides 3? Negative 3. What about negative 3 times negative 3? Would that give us positive 9? Yeah. So could this be both positive and negative 3? Yeah. So I could write a positive, negative like that. Or if you want to write negative 3 comma positive 3 or positive 3 comma negative 3, you totally could. Now, if we look at our original and we see the highest power of 2, how many answers do we say there should be? 2. And how many answers did we get? 2. So it checks out. Okay. Our third step would be to get x by itself, if it isn't already. Is x by itself already? Yeah. So in this one, I'm just going to put in parentheses, hey, this is already done. And I'm just going to note that to myself in parentheses, saying, hey, we already did that. So we're saying if we take either positive 3 or negative 3 and plug it into our original equation, it stays true. Let's see that. Positive 3, what is positive 3 times positive 3 or positive 3 squared? 9. What's 9 minus 9? 0. It's true. Negative 3. What's negative 3 if we square it? 9. Positive 9, actually. 9 minus 9? 0. When we take a negative 3 times negative 3, we get 0. Excuse me, we negative 3 times negative 3, we get 9. Subtract the 9, then we get 0. Don't worry if you didn't understand it this time or if it's still not clicking. We're going to go through more examples. Let me go over a couple definitions, though. Okay, our terms here. First term we're going to learn about is radical. Radical is the square root symbol. So it's just literally the symbol we see. And I'll draw that symbol. Now, you'll see the symbol drawn a couple different ways. That's one way to draw it. I'd say that's probably more common. The way I typically draw it personally is like that. What do you notice is the only difference between those two? The little drop down at the end. So you'll notice I do mine with that little drop down at the end. Most people don't. If you look at a calculator, it doesn't have it on there. Go ahead. The calculator doesn't have that little line there at the end that I put. I've done it. I picked it up from a teacher back when I was in high school, if I remember correctly. And the reason why I do it is just so that way I know when the radical ends. Because sometimes if you see a lot of stuff written together, and you see something after a radical, you don't know whether or not it's supposed to be in the radical. So I just put that just so that way I know where it's ending. And so I know, hey, anything after that would not be under the radical. So that's why I do it. Certainly not a requirement one way or the other. I'm just showing you. You'll see both. Much more common up here on the top. What I use is on the bottom. So we call the symbol the radical. That radical tells us that we're square rooting something. That's the operation for it. That's the symbol for the operation. Now we have this thing called the radicand. These two terms look to be pretty related, don't they? Radical, radicand. We'd say, oh, those probably go together. The radicand is what is under the symbol. So the radicand is whatever is under the symbol, whatever is under the radical. So let's say, for example, I have the square root of 9. 9 is the radicand. Whereas the symbol above 9 is the radical. Does that make sense how there's two parts to every square root there? So you have the radical, which is the symbol itself, the radicand, which is the number or term inside. Yeah?
If you had multiple numbers under there, would they all be the radicand?
Yep, they would together be the radicand. Yeah, great question. Yep. If you had, so, and I'll say that again. Elijah's question was, hey, if you had multiple numbers or multiple terms underneath there, would they all be the radicand? And yeah, the answer is true. That is true. So I mean that they would all be the radicand together. And we'll learn about other things we can do with them. Potentially this year if we get to it. If not, next year. So, yeah. Now, sometimes when you see this, guys, some people will call this the square root of 9. Some people, especially in Algebra 2, this happens a lot, where you start calling it radical 9. It means the same thing. Saying square root 9 or radical 9, you're saying the same thing. So it's just two people saying the same thing in a different way. Anyone still need this before I move on? All right, Gucci gang. Now, we said a moment ago, actually, we talked about this part. When we take the square root of both sides of an equation, we get a positive and negative answer. So, for example, if we had like x squared equals 16, we say, okay, well, I want to square root x to get rid of the square. Okay? Well, I would say, hey, what's happening to x? It's being squared. How do I undo that? I square root. So I square root both sides. And so we say x could be either positive 4, but could also be negative 4. Yeah, because negative 4 squared would be 16 as well. So we often write that positive negative with that plus sign above the minus sign. And I talked to you guys about that last chapter, didn't I? Yes. Okay, and so I'm just bringing that up again now as well. All right, so we're going to solve this first equation by using square roots. So let's go through kind of our checklist that we had up above. What was that first step for our little checklist? There was 3 steps there. What was our first one? Yeah, isolate the square root, aka get it by itself. Or get the squared term by itself. I said square root. Get the squared term by itself. So we say, hey, what is being squared? X. Is x squared by itself? Yes, first step's done. What's our second step? Take the square root of both sides. So once the square turns by itself, we can take the square root of both sides. Mathematically, what happens here is the square root and square undo each other. Addition and subtraction undo each other. Multiplication and division undo each other. Square and square root undo each other. So what do we get if we take the square root of x squared? Just x. Equals, what's the square root of 4? 2. But do we just write positive 2 here? It could be positive or negative 2. It could be either. Okay. And then our third step is to get x by itself. Is x by itself? Cool. We're already done. Now, alternatively, if we wanted to solve this a different way, don't write this part down. Okay. What we could have done was we could have taken this equation, x squared equals 4. We could have said, okay, let me subtract 4, x squared minus 4 equals 0. Would that look pretty familiar to what we saw before today? Yeah, and we could factor that out and say x minus 2, x plus 2 equals 0, and solve both of those and get the same answers. So you still can use either method. So hopefully you guys are seeing, oh, maybe there's an advantage to this method, maybe there's an advantage to that method, oh, maybe it depends on how they're set up, maybe it depends on my preference. But I want you guys to be able to use both methods. Number two, okay? What's our first step? Okay, add 36 to both sides to isolate the squared term. Okay, so Elijah said what the step is. Courtney said the y. So x squared will equal 36. So now we ask ourselves, is the squared term by itself? Is it isolated? Yeah, x squared is by itself, okay? So now our next step is to do what?
And the square root of 36.
Take the square root of both sides. So we take the square root of x squared, and then, because we took the square root of the left, we have to do it to the right. What's the square root of x squared? X. The square and square root undo each other. And do we know the square root of 36? 6. Now wait, is it just positive 6? Positive and negative 6. And is x already by itself on this one? Yeah, it is. So we're done. Questions on number 2? Yeah, Josh. How does square rooting work? Great question. So square rooting works by saying, it actually works by a mathematical, memorization, really. So square rooting mostly works on, memorization to undo a square. And so us knowing the square root of 36 is 6. Like us just knowing 6 times 6 is 36. Because otherwise you'd have to guess and check to figure out what times what would be that number. Does that make sense? And so when you have numbers like, 5, does anything times itself equal 5? Well, no, it's actually just a really long string of decimals. It's going to be like 2.3 something, and it's going to keep on going forever and ever and ever. Because the calculator has it programmed into it already of exactly what it ends up being over time, approximately what it ends up being because it rounds. Does that answer your question? Kinda. Calculators work because they are programmed, so they are just programmed with math facts. And so they just spit out things just as if you were to ask me a question, and if I just know it by memorization, that'd be basically like, what?
2 times 2.
4. That'd be like a calculator. That's essentially the same as what a calculator does. You tell it, it gives you the fact. All right, let's go on to number 3. Number 3, what would be our first thing to do here? Get x squared by itself. Get the squared term by itself. Okay, notice I keep saying the squared term because it won't always be just x that's being squared. We're going to see in later problems that it's not just x that's squared sometimes. So get the squared term by itself. In this case, x squared. So, how do I get x squared by itself here? I start by adding 2. 2x squared equals 2. Is x squared by itself? No. What else is happening to x squared? Being multiplied by 2, so we have to divide by 2. On both sides. Once again, whatever I do to one side, I do to the other. X squared is equal to 1. Now is the squared term by itself? Yeah. Okay, so what do I do now? Take the square root. I square root both sides. What's the square root of x squared? X. We know that x times x is x squared. And we know the square root and square undo each other. What's the square root of 1? 1. Is that our answer? Positive and negative 1. Don't go through all that work just to forget half your answer at the end, okay? Remember that positive, negative. Questions on that? All right, let's go on to number 4. I want you guys to try number 4 on your own. Raise your hand when you have or have questions. Most, though. So on this one, what's our first step to do here? Brady? Add 6 to both sides, right? because we got to get the squared term by itself. X squared is 25. Ha ha ha. The funniest number, right? Now is the squared term by itself? Gucci. Okay? So now what do we do? Square root both sides. Oh, not like that. What's the square root of x squared? X, they undo each other. What's the square root of the funniest number? Positive and negative 5. Questions on that one? All right, on number 5 here, what do you notice is different? Yeah, the quantity is being squared. X plus 3 is being squared. So here, is x the only squared term? No, what is the squared term this time?
X plus 3.
X plus 3, the whole thing. This whole thing is being squared. So, when we ask ourselves this question, is the squared term by itself? Yes. It actually is. Believe it or not, the squared term is by itself, because is anything with x plus 3 right now? No. So the squared term is, in fact, by itself. Okay, that's why I kept saying squared term, squared term, squared term instead of x squared, x squared, x squared. Does that make more sense now, maybe? Okay. Because I knew, hey, we're going to have a problem like this coming up. So we can move on from step 1 to step 2. What's step 2? Square root. Now, what does the square root and square do to each other? They undo each other. They undo each other. They're inverse operations. So we're going to be left with x plus 3. Whenever you square root a square, you're left with whatever was inside besides the square. You're left with whatever's inside beside the square. So in this case, it's x plus 3. What's going to be the square root of 4? Or square root of 16? 4. Positive and negative 4. Now wait. Is x by itself yet? No, so this is the first time we've had to do that step number 3, right? We haven't had to do step number 3 yet. So for step number 3, what do we have to do to get x by itself still? Subtract 3. Wait, how do we know whether we're subtracting 3 from positive 4 or negative 4? Pick one. What do we do? Okay. Well, actually, what you have to do is you have to split the equation. We're going to be splitting this equation into 2 different forms. Because it could be because there's going to be one scenario where we have positive 4 minus 3. There's going to be another scenario where we have negative 4 minus 3. So we actually have to write 2 different equations. One of them is going to be a positive 4 minus 3. The other one is going to be a negative 4 minus 3. So whenever you have these 2 symbols here, positive, negative like that, and we have more math going on, whether it's addition, subtraction, division, multiplication, whatever it is, we have to split the equations. Okay, have to. And what we're going to do is we're going to split the sign, the plus and minus that we put together. We're going to split it back apart. So just like how we said we could write a positive 4 comma negative 4 together as positive or negative 4, we're splitting them back up into positive 4 and negative 4. So then when I solve, what is 4 minus 3 over here on the left? 1. What's negative 4? I forgot my equals on that one. What's negative 4 minus 3? Negative 7. So those are my 2 answers. 1 and negative 7 are my 2 answers. Okay? And play with me for a moment here. If I plug in 1, what is 1 plus 3? 4. If I square 4, do I get 16? Yeah. Negative 7. What's negative 7 plus 3? Negative 7 plus 3, I heard it? Negative 4. What's negative 4 if it's squared? 16. So do both work? Yeah. So even though they aren't like a positive, negative of the same number, there still are 2 answers. Okay? Questions on number 5. That one was a bit different. Okay? Oh my gosh, class is almost over. Okay. My bad. I did not realize we were almost over already. Okay. Let's try number 6 here real quick. Number 6, 2x plus 1 being squared equals 16. Okay, is the squared term by itself? Yeah. So square root both sides. And what do we get on the left-hand side? 2x plus 1. What do we get on the right? Positive and negative 4. So once again, I'm going to subtract 1. Not once again, but I'm going to subtract 1 to get x by itself now. 2x is equal to positive or negative 4 minus 1. Now what do I have to do to get x by itself? Divide by 2. On the entire side, right? So x is equal to positive or negative 4 minus 1 all over 2. Now does that look like a clear number to us? No. So what we do is we split the equation into one scenario where it's x equals positive 4 minus 1 over 2. The other where it's negative 4 minus 1 over 2. These scenarios are almost identical, right? The only difference is that positive or negative 4 became a positive 4 and a negative 4 in the different scenarios. Questions on how or why we split that? Okay. The left equation, 4 minus 1 is 3. 3 over 2, I'm okay with us leaving it that way. Second equation, what's a negative 4 minus 1? Negative 5 over 2, I'm okay with leaving it that way. Those are the two answers there. All right, so once again, we're pausing here. And for now, I want you guys to do numbers 1 through 4, as well as 9 and 11. So I'm assigning those 6 problems for now. So I guess a little under half. So once again, guys, an exact answer is not rounded. It contains the radical unless the radicand is a perfect square like we saw earlier. An approximate answer is going to be rounded and it'll be written as a decimal. So we said the square root of 12, it's not a perfect square. So that is exact because it's exactly that. Amy, put that away. But 3.46, oh, it's on the calculator. But 3.46 is approximate. Okay, that's an approximate. That's close to it. Because in your calculator, Phoenix wrote off this long strand, and it actually goes longer and longer and longer. It goes on forever. Okay, it never ever ends. You guys remember talking about at the beginning of the year numbers that never end, never terminate? They're called irrational. Okay, that's an irrational number. The square root of 12 is irrational because it's 3.464101 keeps going forever. It rounds somewhere. So once we round it off, it's no longer exactly that. So we can't claim that it is. We're going to use a symbol for that instead of saying it's equal to something. We're going to say it like this: the square root of 12 is approximately 3.46. We're going to have those little squiggly signs, okay? It's like instead of like an equal, it's rigid, it's straight. It's like, oh, I know it's exactly this, okay? It's a little curvy. It's less confident in that. If that makes sense. It's close to this. It's about that. And I'm going to ask us to round to as many decimal places as specified. So it's going to be on here. It's going to say, oh, go to this many. Okay? So I'll talk about how we get there, how we give both exact and approximate answers, and then round to the 2 decimal places, okay? So x squared equals 8. Is the squared term isolated? Yeah, x squared is a square term and it's by itself. So what do? Square root both sides. What's the square root of x squared? X. Do we know the square root of 8? No. So we call it, before we pull out our calculators, please wait. Please wait before we're pulling out calculators. Okay. We say x is equal to the positive or negative, because we have to take into account both, the square root of 8. That, just so you guys know, you don't have to write this down, is the exact answer. That's the exact answer. Okay? Now we can say x is approximately positive or negative. And I'll pull out some calculators and I'll teach you how to use the calculators so that way you know how to use my calculators as well as the ones you have with you, maybe on your phone or something. On this calculator, my TI-30X, you can see that at the top right-hand corner of the calculator that says that. That's what type of calculator it is. What you do is you first turn it on by hitting the bottom left on button. Then, if you look on the left-hand side, right next to the 7, you see the button that says x squared. Is that correct?
Yes.
Okay. Now, right above that x squared, before you get to the next button, what do you see in a lighter shade or a different shade? The square root symbol, the radical, right? So, you see how that shade, it kind of matches the shade of that second button up at the top left?
Yes.
Yeah. So hit the second button up at the very top left of your calculator. Then, push the x squared button. Did you end up getting the radical in your calculator?
Yeah. I did.
If so, you're doing it correctly. Now we type in 8. And you close your parenthesis, that's right above 9. And you push enter.
2.82.
Okay? And so if we round to the nearest two decimal places.
2.82.
Nope. 2.83. How do we know it rounds up to 2.83 rather than rounds down? Because there's an 8 afterwards, right? The third decimal is an 8. If the third decimal was a 4 or below, we round down. If it's 5 or above, we round up, right? Okay? Now that is the approximate. So when I'm asking for both answers, this is what I'm asking for. Does that make sense?
Do we need both answers on both? I mean, on all of them?
On these right now, yes, because it says to give exact and approximate.
Are we going to put it over?
When it asks to, yes. Okay? Now, we'll find out in a moment that there's somewhere you actually don't need to. There's somewhere you don't need to find the approximate because it's already a perfect square like we saw in the previous problems, okay? Now, how you would do that on a phone, okay? If you have an Android phone, you actually do the same exact thing you just did based on this calculator. If you have an iPhone, though, the iPhone calculator is not quite as nice, so you flip the phone. You have to have portrait orientation lock off, okay? Or you can do it on your iPad as well. Then you take 8, you type in 8 first this time. And then you hit the square root button. So you type in 8 and you hit the square root button. Make sure when you type the square root button, you do the radical with the 2, not the radical with the 3 or the radical with the x. Do the radical with the 2. Okay? And do you get the same thing?
Yeah.
Good, good. If you don't, you did something wrong, and I can help you with that. All right, let's go ahead and move on to example 2. Example 2, we have x squared minus 2 equals 13. Is this squared term isolated?
No.
No, what do we need to do?
You need to
Add
add 2 to both sides.
2 to both sides. X squared is equal to 15. Now is the squared term isolated? Yes, so we're ready to square root. What's the square root of x squared?
3.
Nope. What's the square root of x squared? X. Do we know the square root of 15? Is it a perfect square? No. So we need to give an exact answer. So x is exactly a positive or negative square root of 15. Now, when you're just saying, trying to measure something or something like that, is square root of 15 very helpful for measurements?
Oh, really?
Probably not. So it's going to be more helpful to have the approximate here. So x is approximately positive or negative. Type in your calculator. Round it to decimal places. No blurting here. Go ahead and write down what you get. Not yet. All right, raise your hand if you want to share what you got. What would get to 2 decimal places? Jill. 3.87. Very good. 3.87 is the approximate. Now, do I need to label which one's exact or approximate, or is it pretty clear to tell? The symbol is one way to tell, the equal sign versus the approximate symbol, the squigglies. And you'll see one with the decimal and one with the radical, right? Very good, very good. Now, we were on a problem earlier where you get this answer. Is there any need to do an approximate? No, because is a perfect square. So you don't need an approximate. The only times you need an approximate is when it's not a perfect square, like on these. Okay? I want us to do 2 more. So we have 3 more here. I want us to do 2 of them, okay? Let's look at number 3. X plus 2 being squared is equal to 6. Is a squared term by itself? Yeah. So we square root both sides. What do we get on the left side? X plus 2. On the right side, do we know the square root of 6 off the top of our head? No. That's not a perfect square. So it's a positive or negative square root of 6. Now wait, is x by itself yet?
No.
No, it's not. So we subtract 2. Now, do I know what the square root of 6 minus 2 is?
Yeah.
No, I really don't. But I can write positive or negative square root of 6 minus 2. That is my exact answer. Really, really. That is going to be my exact answer. Now, to find my approximate,
You'd actually subtract 2.
I would actually subtract 2, and I have to split the equation, right? Now, we type in square root of 6 into our calculator. We round to 2 decimal places, and we say, that's approximately positive or negative what? 2.45 minus 2. So now we have to split our equation because we have a positive and a negative, right? So now we're at the point where we split our equation. Split it into 1, split it into 2. X is approximately 2.45 minus 2. And x is approximately 2.45 minus negative 2.45 minus 2. So we say, okay, well, the left one, what's 2.45 minus 2? 0.45. What's negative 2.45 minus 2? Negative 4.45. Those are my 2 approximate answers. And my exact answer was up here right before I switched to decimals. So my exact answer was way up here, x equal to positive or negative square root of 6 minus 2. My approximate went much farther, didn't it? Okay. Questions on that? Okay. See, yep, I'm going to have us do 5 real quick. Okay, we're going to skip 4. Is the squared term by itself on 5? Yeah, so let's square root. We're going to be left with 2x plus 3 is equal to the square root of 7. Wait, do we know what the square root of 7 is?
No.
No, okay, so we just call it the positive or negative square root of 7. Okay, now is x by itself? No. Subtract 3. Once again, we don't know what that is, but we can write it. 2x is equal to positive or negative square root of 7 minus 3. Is x by itself yet? Still no. Divide by 2. Divide everything by 2. X is equal to positive or negative square root of 7 minus 3 over 2. Is there anything more we can do without rounding? No. So that means this is my exact answer. Now, did I just ask for the exact answer here, though?
No, you want the
No. I want the approximate too. Now, if I did ask for the exact answer, would we be done?
Yeah.
Yeah, but I asked for the approximate as well. So now we have to approximate. What is the square root of 7 approximately? 2.6. I'd actually think we round up on that one. Is that true?
0.7.
Oh, yeah.
Yep, 2.65. Minus 3 divided by 2. So now, can we split this? Yeah, now we split this. And did we do something like this earlier?
Yeah.
Yeah. So we split it, and we get x to be approximately 2.65 minus 3 divided by 2. X to be approximately negative 2.65 minus 3 divided by 2. And it's okay for us to use our calculators on this one if we want. Just make sure you do them as separate problems, or you subtract and divide first. So here, what's 2.65 minus 3?
0.35.
Yeah, negative 0.35, and we're going to divide that by 2. So go ahead and do negative 0.35 divided by 2.
Negative
X is approximately negative 0.18. Because I said round, or 0.18. Because I said round to 2 decimal places. That'd be correct, yeah. So that's one answer. Now we need to go back and do our other one. On our other one, negative 2.65 minus 3. It's going to be a negative what? I heard it? 5.65 divided by 2. And when we divide those by 2, we end up getting x to be approximately what?
2.8.
Yeah, negative 2.8. If we round to the nearest, our 2 decimals. Negative 0.28. So see how we end up getting, it looks like 3 answers, but it's really 2 exact answers, 2 approximate answers. So say it's exactly this. Once we enter into the world of rounding, we're no longer exact, but it's approximately these. Questions on that? Okay. On a homework, when I say exact and approximate, and it ends up being a perfect square, do you need to give me the approximate? No, it's already done. Okay.